Hello viewers. So in today's class we are going to discuss one important mean value theorem in differential calculus, that is Rolle's theorem, right? So here we are not going to give an algebraic proof of Rolle's theorem. Instead we'll explain or will prove Rolle's theorem in a geometrical way, right? And while taking the geometrical interpretation of Rolle's theorem, we'll make use of sine function, right? So let us start. Now let us first take the formal statement of Rolle's theorem. So now the formal statement of Rolle's theorem is let fx be a real valued function, and it is defined on the interval a comma b, right? Now the function f, it satisfies three properties, right? So if the function f of x satisfies these three conditions, then we have this condition, right? So what are the conditions? Let fx be a real valued function, and it is continuous in the closed interval a comma b, and it is differentiable in the open interval a comma b, and the value of the function at these 2 points at a and b are equal. Then Rolle's theorem says that if these three conditions are satisfied, then there must exist a real number c belonging to this open interval a comma b, such that the derivative of the function at this point c should be equal to 0, right? It means at that point, what is the point? The point is c. So at the point c, the tangent must be parallel to the x-axis. Now to explain Rolle's theorem, let us take the example of sine function, right? Suppose we have the function y is equal to f of x equal to sine x. So here we are taking the function sine of x, and let us draw the graph of sine function. So the graph, it looks like this. So here we have the graph of sine x, and we'll take this graph to this side also. So here we have the graph like this, right? So viewers, here we have a rough sketch of the sine function, and here we have the angles. Here we have 0, and here we have pi, here we have 2 pi, here we have 3 pi, and here we have 4 pi, and so on. And here we have minus pi, and here we have minus 2 pi, right? So this is the graph of sine x, and here we have plus 1, and here we have minus 1. So now let us take these points one by one, right? So the Rolle's theorem says that let fx be a real valued function defined on some interval a comma b. So here let us take the interval, say 0 to pi, right? So here we are taking this interval 0 to pi. Okay, now the first condition, that the function f of x should be continuous in a comma b. So obviously the sine function is continuous. So sine x is continuous in the interval 0 to pi. The second condition is the function should be differentiable in the open interval a comma b. So we know that the sine function is differentiable, and the derivative of sine x is f prime of x, that is cos x, and the function is differentiable in the interval 0 to pi, right? And the third condition, it says that f of a should be equal to f of b. So here we have f of a means f of 0, because this is a and this is b, right? So f of 0 is sine of 0 and it is 0, and f of pi is sine of pi, that is 0, right? So obviously f of 0 is equal to f of pi. So we see that this function, it obeys all the three conditions of Rolle's theorem. Then Rolle's theorem says that there must exist at least one real number c belonging to this interval, such that the derivative of the function at that point must be 0. So here we have f prime of c, right? X is equal to c, then f prime of c is cos of c. Now if we look at this graph, that is from 0 to pi, right? From 0 to pi. So this is 0, this is pi. So we see that at this point, right, that is at point pi by 2, we have, that is at x equal to c is equal to pi by 2, we have f prime of pi by 2 is equal to cos of pi by 2, which is equal to 0, right? So it means at the point pi by 2, the slope of the tangent is 0. So slope is 0, it means the tangent is parallel to the x-axis, right? So here we have the tangent. So here we have f prime of pi by 2 is equal to 0. So this is how we can explain Rolle's theorem with the help of this sine function. So here if we take the interval 0 to pi, then there is at least one point. Rolle's theorem says that when a function satisfies all these three conditions, then in the interval a comma b, there must exist at least one point at which the derivative of the function must be equal to 0, right? So here we have in the interval 0 to pi, we have only one point, right? So now let us extend the interval, and then we'll see how we get more than one point between the given points or the interval. Now let us take the same function, that is y is equal to f of x is equal to sine x, right? And let us this time take the interval, this a comma b, as from minus 2 pi, from this point, right? From this point to say this point, right? From minus 2 pi to 2 pi. So here we have the value of a as minus 2 pi. This is b, right? So this is b. Okay. So now in this case, again we can take sine x is continuous. Sine x is continuous in the interval minus 2 pi to 2 pi, and the derivative of sine x exists in the interval minus 2 pi to 2 pi. It means f prime of x is equal to cos of x. It means the function sine x is differentiable. It is differentiable in the interval minus 2 pi to 2 pi, right? Okay. And the third condition, which is quite important. So the third condition is f of 2 pi. F of 2 pi is sine of 2 pi, which is equal to 0, and f of minus 2 pi, that is sine of minus 2 pi. So we have minus of sine 2 pi, that is 0, because sine 2 pi is 0, right? Okay, so we have seen that f of 2 pi is equal to f of minus 2 pi. So therefore all the three conditions of Rolle's theorem are satisfied by this function in this interval. So sin x is continuous in this interval, sin x is differentiable in this interval, and f of a is equal to f of b. It means at the endpoints of the interval the value of the function is same, that is here in this case it is 0. So Rolle's theorem, it says that there must exist a real number c belonging to this interval. So here our c, it must belongs to this interval, that is minus 2 pi to 2 pi. So let us now find the values of c with the help of the graph, right? Okay, so now what we will do, we'll see the graph and see here we have minus 2 pi and here we have 2 pi. So this is our A and this is our B, and between these 2 points we see that we have 1, 2, 3 and 4. So we have 4 points, right? We have 4 points at which the derivative is 0. So it means we have 4 values of c, c1, c2, c3 and c4. So Rolle's theorem says that if all these conditions are satisfied, then we must get at least 1 point between these 2 points where the derivative is 0. So here we have 4 points. It means we have more than 1 point. So c1, c2, c3 and c4. So let us find what are c1, c2, c3 and c4 with the help of graphs. So here we have say if we take it c1, this is c2, this is c3 and this is c4, right? So here we have c4. So c1 is, here we have c1, so here we have minus 3 pi by 2, right? So c1 is minus 3 pi by 2, c2 is minus pi by 2 from the graph, c3 is pi by 2 and c4 is 3 pi by 2, right? So this is how with the help of graph we can explain Rolle's theorem. Now at these 4 points we see that the tangent is parallel to x-axis, right? Tangent is parallel to x-axis. So when tangent is parallel to x-axis, the derivative must be equal to 0 at that point. It means the slope is 0, right? So here we have f prime of c1 is 0. Here we have f prime of c2 is 0. Here we have f prime of c3 is 0, and here we have f prime of c4 is equal to 0, right? In the interval minus 2 pi to 2 pi. Now here we have calculated the values of c1, c2, c3 and c4 with the help of graph, but we can also find these 4 values by solving this equation, and let us see how. Now we have this function, that is y is equal to f of x equal to sine x, it satisfies all these three conditions in the interval minus 2 pi to 2 pi. So there must exist a value c belonging to the interval minus 2 pi to 2 pi such that f prime of c is 0 and f dash of x or f prime of x is cos x. So f prime of c equal to 0 means cos of c is equal to 0. Now this is a trigonometric equation and we have to solve this trigonometric equation within this interval. So what we will do, we know that the general solution of the equation cos theta is equal to cos alpha is given by theta is equal to 2n pi plus minus alpha, right? So we know this general form, and with the help of this general form we can find the solutions to this equation. So cos c is equal to 0, so cos c can be written as cos c is equal to cos of pi by 2, because cos of pi by 2 is 0. So this is now theta and this is alpha. This is alpha. So the solution is c is equal to 2n pi plus minus pi by 2, and here n is an integer. So now here we have n as an integer, so n can take value 0, plus minus 1, plus minus 2, plus minus 3 and so on. So here in this general solution we can substitute different values of n to get the particular solutions. So if I take n is equal to 0, then obviously we'll get c is equal to 2 times 0 times pi plus minus pi by 2, which is equal to plus minus pi by 2. So here we have one value as pi by 2 and other is minus pi by 2. So this is c3, that is pi by 2, and this is minus pi by 2, which is the value of c2, right? So now this is how we can find the values. Now let us substitute the value of n as say 1, right? So when n is equal to 1, then we have c is equal to 2 pi plus minus pi by 2. So we'll take only the negative sign here. So we have 2 pi minus pi by 2, which is 4 pi minus pi, that is 3 pi by 2. So this is 3 pi by 2. So here we have 3 pi by 2, right? So this is the value of c4, right? So this is 3 pi by 2, and here we have not considered the positive sign, because if we take the positive sign, then we'll have the value of c as 5 pi by 2, and 5 pi by 2 does not belong to this interval, right? Okay, so now we have to find the value of c1. So for c1, what we will do, we'll take the value of n as minus 1, right? So we'll take the value of n as minus 1. So here we have c is equal to minus 2 pi and plus minus pi by 2, and taking the positive sign here, we have minus 2 pi plus pi by 2, and this is minus 4 pi plus pi by 2, that is equal to minus 3 pi by 2. So here we have this value as minus 3 pi by 2. So this is the value of c1, right? So viewers, this is how we can find the different values of c with the help of solving the equation f prime of c is equal to 0, but we can also locate the points with the help of graph, as we have discussed earlier.